Dear students, today we will discuss one of the important problem when different processes are competing together for different resources. And today's topic we will discuss semaphores. Before reaching to the definition of semaphore, we must consider a scenario. So for example, process A wants to use a printer. So, what would be the logical order which comes into your mind? If the printer is available, then we should give the printer to process A. However, if the printer is not available, then process A should wait. So, how to basically store that thing that printer is available or not available? So one of the process or one of the way to track such printer availability is using a single bit. And we say that 1 means that printer is not available and 0 means that printer is available. So 1 we will be called set and 0 we will be called clear. So this means we have two instructions, set and clear. Set mean 1, printer is not available, so please wait. And clear 0 means printer is available. So this means, this is a very easy way to check whether the printer is available or not available. And we can put this information in 1 bit in the main memory. So let's see that if we store such a bit, whether it would be okay or it may have certain problems. So for example, here is a memory and here it is written 0. So this 0 means that printer is available. So process A is here. I am noting it with PA, process A, that reads this information. You know that when process A want to read this information from the main memory, what would be the procedure? The procedure is there are 3 steps. One is the retrieval. Second is processing in CPU, that whether it is 0 or 1, and then third is set instruction, which will do it or which will set this bit as 1, that I am going to use this printer. So when this process A was reading this bit and taking this into the CPU for processing in the registers, that whether this bit is 0 or 1, at that time another process, process B, also read this bit. So process B also find it as 0, and in the same time the process A has evaluated that this is not 0 and it goes back and try to do it as 1. But process B has already read it as 0. So this means that this set and clear instruction, as it had 3 sub instructions, so this means that if after the execution of first instruction any other process reads the memory slot from main memory of this bit, whether the printer is available or not, so that would be misguided. So this means this printer will be allocated to process A and process B because both read it as 0. So what is the solution? One of the solution is that we should disable the interrupts. So for example, when process A want to go to read that bit, it says interrupts are disabled. So when you do in your daily life, for example, when you are reading very critical section in your book, then you paste a signboard, do not disturb. So this means that you are giving a signal to someone that I am doing very important work and in this time you should not disturb us. So similarly, one of the solution is to disable the interrupts. So this means process B cannot initiate an interrupt while first instruction is executed, that is reading. Second instruction is executed, that is the CPU instruction, the if condition, whether the bit is 0 or 1, and the third instruction, which is setting the value to 1. After all of the execution of these three steps, that process A will say, okay, now you can disturb us. So it will say interrupt are enabled now. And second solution is that test and set instruction should be executed in one cycle. So in certain CPUs, such a machine instruction is available that you can test whether it is 0 and you can set at the same time within the same machine instruction. So this means you do not need 3 instructions. So within that particular instruction, no one can interrupt you. So a properly implemented flag, whether with the solution number 2 or solution number 1, is known as semaphore. And then there is a concept of critical region. So you might have known that there is a very famous example of train track. So on railway tracks, there is a dedicated track on which if one train is put on that track, then other trains are forbidden to go to that track. So this is called a critical region. So this means that critical region instruction. So this means that when process A is executing these 3 instructions, so then it is in a critical region. And we can say that at one time, one of the process can execute this critical region. And such a terminology is known as mutual exclusion. That the requirement that at one time, one process can execute critical region is called mutual exclusion. So if we summarize today's module, we have learned a very well-known problem and we have used 2 solutions to handle that problem using semaphores.